So the question is to factor by grouping the expression 2w to the third plus 5w squared plus 14w plus 35. And this is an expression with 4 terms, and no 2 of these terms are like to one another, right? So we can't simplify what's here because each of the terms has a different degree to each other term. So here's where I start in a problem like this. I'm going to go back to this grid again. And I'm just going to put my 4 terms into this grid. So starting with 2w to the third, and then plus 5w squared, and then plus 14w plus 35. Okay? So in other words, I'm using this grid now in a backwards fashion. When we used it a moment ago, we were starting from the outside and moving in. Right? So when we were using this grid to multiply, we started from what was on the outside of the rows and the columns, and then we figured out what belonged on the inside, because we're multiplying. But when we're factoring, we're doing the opposite. We're starting on the inside, and we're trying to move outside, trying to figure out what belongs here and then what belongs here, because those are going to be our factors for our final answer. So that's the general shape of how I use the grid to do this. And here's my take. Here's how this works. We start by focusing on one row of this grid. And for the sake of starting somewhere, let's start on the first row. So I'm going to start here on this first row and ask how to factor out the greatest common factor of these 2 terms. What is the greatest common factor of 2w to the third and 5w squared? 10 would be the least common multiple of the 2 and the 5. I'm asking what? So 2 and 5, right, 2 and 5 only have 1 in common. So I can't bring any constant factor out in this GCF. How about between w to the third and w to the second? W to the third is the larger of the 2 powers, so that would be a common multiple. A common factor is what's in common to both. Right, they actually have 2 powers of w in common. We pick the smaller of the 2 exponents when we're finding the greatest common factor. So the greatest common factor of the pair of terms that are on the first row of my table here is w squared. And that is the little nudge that gets our snowball rolling down the mountain in this technique. Because now that I've factored out w squared from the first row in this table, I can figure out what belongs here and what belongs there. What do I have to multiply? So if I'm looking right here for the moment, what do I have to multiply w squared by in order to get 2w to the third? What's it missing? 2w. Exactly. It's missing the 2 as the coefficient. It's also missing 1 power of w. Now, sliding to the right, what do I have to multiply w squared by to get 5w squared? 5. Just the constant is all it's missing. And so, lo and behold, we've actually discovered one of the factors in our answer, probably 2w plus 5. And our second factor, we know it has a w squared. All we have to do now is figure out what that second term is by, again, playing the same game. If I want to know what belongs there, I have to know what do I multiply 2w by in order to get 14w? 7. And so we expect w squared plus 7 is that first factor. Let's verify, because there's one piece of this table that we haven't checked, the 35. Well, does it work? 7 outside, yeah. 5 outside. Yeah, it works. 7 times 5, 35. So we did it. So we factored this by grouping without... I like this because it doesn't rely on the sort of preternatural vision that authors of algebra textbooks often assume that people have at this point, which if you don't have a lot of expertise in this area, you don't. And even as a mathematician, I don't factor by grouping very often. And so even if I'm trying to do it the way that the book recommends doing, I often struggle. So I like this as a little device to help make this process more consistent and make it rely less upon the sort of artful stroke of observing some deep structure in the problem, which is what the other method kind of relies upon you doing. So I like the strategy for factoring by grouping that puts all of the terms inside of a grid, like this one, and then focuses on one row, factors its greatest common factor out to get the process started. Getting to here, I think, is the tricky step, because once you're there, then you know how to fill in the rest of the table.